Okay. All right. So, can somebody recall what was done in these two lectures? Um, Environment and this one. It's a very important idea called closures. And yeah. So, did you get time to watch the videos? Those two videos. Yeah. Hello. Did somebody watch the videos? Nobody watched the videos, huh?
Yes, sir. We
Yeah.
did.
You watched the videos? Okay. Yeah. So can you remind me, can you recall what is this idea of environment and what are frames and yeah, things like that. What is environment? What are frames? And what happens when you execute a procedure and things like that? Hello? Nobody remembers?
Sir, I also watched. I can try.
Yeah, I didn't catch that.
Yes, sir. I was saying I also watched it, so I can try explaining.
Yeah, please go ahead.
So basically, the thing was that thus what it is saying is that when we mutate things, then our substitution model breaks down,
Mm-hmm.
because then at different points of time we are not sure whether it points to the same thing.
Yeah.
So then we bring in the concept of an environment where it is like I understood it intuitively as something that everything has an environment, and then what we do is we first check the most local environment, the value of anything, and then we move upwards. So at any point, if we find the value with a particular name associated, then we make use of that value in the particular frame, say where our procedure is called.
Mm-hmm.
So that helps us understand how things are, like when things are changing with time, how do we keep track of the values.
Mm-hmm. Okay, and so what are the differences between define and setback?
So define will create a binding, whereas setbang will first find the binding and then alter it. And if it does not exist, it will throw an error.
Yes, fantastic. So define creates a new binding. A binding is just a pair of a variable comma value. Yeah, that's called a binding. So if define just creates a new binding in the current frame, and setback instead finds the existing binding of a way of the given variable and then alters its value. Yeah, that's the difference between setback and define. Okay, that's fine. Now, what happens when you create a new procedure? I mean, so how are functions executed? Like in terms of environments, what can we say about what happens in when you execute a function? Because that's very important. Yeah, that is our key to doing object oriented programming is this idea about closures. Yeah, environment and when you have a lambda, when you create a procedure that and when you execute a procedure, there are some things which happens with the environments. That's what I'm asking.
So when you create a procedure, it creates another frame and it binds the frame to the procedure in which, sculpts the frame into in the environment in which the procedure is defined. And within this new frame, it binds the local variables with their values assigned.
when you create a procedure. You go slowly. That is when you create a procedure. So when you create a procedure, it attaches the procedure to the environment in which it is created, and with a yeah, that's what happens. Now when you call a procedure, or when a procedure is executed, a new environment is created in which the procedure will run, and this procedure will have its enclosing frame as the procedure in which it was the frame in which it was created. Yeah, is that clear? Hello. Okay, so I hope it is clear to everybody, because that is the key idea when we go into object-oriented programming. Yeah, because what are objects in scheme? Objects in scheme are nothing but
Procedures.
Procedures with their associated environments. Yeah, and those are when you look at Python or C++, is exactly the same. Yeah, procedure, an object is a bunch of methods with some associated data. Yeah, that encapsulation, that packaging is called an object. And in scheme, you see that idea in a much more bare bones style, in which an object is nothing but a procedure, but with an environment associated with it. Okay. All right. So let's try to do. And okay, one more thing. And and how do objects communicate with each other? By sending messages. Yeah. So have you seen this sending messages idea? You have seen a couple of examples in the slides now. Remember? I mean, is it clear to everybody, or is it too difficult? I don't understand. No answers. Hello. Did everybody understand what is going on in the last two lectures? Let's do an example. Uh, let's create stack object. Yeah. So let's create stack as a class. Yes. Stacks in OP. Okay. Now, so how do I proceed? Can somebody help me? How do I create a stack in my object-oriented programming style? Let me get started, so then you can help me. So I define, and I need to I need to make stack, and let's, for the moment, let it be like that. Make stack, and this is nothing but a procedure which takes a message, and what should that message do? It's a count. And what are the messages we typically have in stack? So we'll have push, and we'll have pop. So we have to insert something here, and we have pop. And we have, okay. All right. So this is what we are going to do. And if I say define X make stack. So here also I'll need some things. Make stack. Then it will X will be a stack. This is what our idea is. Everybody understand so far?
So I have a doubt.
Yeah.
So for define make stack,
Hmm.
is the input going to be a stack itself? Because if it does not have a binding that is inside that state of the Lambda procedure, then what is it that we will be manipulating in terms of data?
So we need to have some data. You are saying make stack.
Yes,
Yeah. Of course, we are going to have some. But right now, I just wrote the skeleton. What is this make stack operation does? Make stack operation is going to be a procedure which takes two messages, push and pop. That's all I know so far. Yeah,
okay, sir.
because the stack is an abstract data structure which takes two I mean, one of two of its operations are push and pop. Yeah, that's all. We now what should be our make stack? Our make stack should behave as a stack. So it needs to have a variable, a storage which acts as a stack. So how can we represent a stack? We can represent it as a list. Yeah. And therefore we can in this along with the procedure for lambda in its environment we can put a stack, we can put a list s. Yeah. So now when we create a stack, we will take a list as input. Typically it will be a empty list. Yeah. So here when I say make stack, I am actually creating an empty list. Yeah. Is it clear to everybody what I'm doing? Nobody's answering. Hello.
Yes, sir.
Did you under? I'm going to ask somebody. I mean, okay. So then, who is going to tell me what should I put in push? What should I put in push?
So you should have one procedure which will take an element and it will insert that element into the list.
Yeah. Okay. So along with the message push, I need to take an element as an argument. Yeah. So now this is where the dot operator comes in handy. What does the dot operator do? It allows you to take arbitrary number of procedures, arbitrary number of parameters to a procedure. So when I say lambda message dot args, it has to take message as at least that many, at least it has to have one parameter called message, and then it can have an optional number of parameters called arguments. Yeah, you have the same this thing in Python also. There are some default arguments thingy, and yeah. So now if I take message along with the push, what should I do now? I should add that new element to the front of this list. So it should be, what should it be? Set bank. Yeah. Set bank. I can just make S to be cons of char of AR args and S.
Sir, can't we use the sat char directly?
If you do the set char, then we will remove the topmost element of S, no? You mean like set char S something. In
Yes.
that case, we will remove the char of S. So we don't want to replace that. We just want to add an element to S. Yeah.
Okay.
Sir, while pushing, we will be sending only a single element. So why there is a need of car arcs?
Yeah. Because yeah, I could actually just put yeah. So now somebody, how do I reclaim reclaim host? Okay. All right. Where were we? Okay, so the point is that when you have a procedure which takes some arguments, the fixed arity is the number of arguments any function takes. Okay, that arity comes from the word uh, unary function, binary function, tertiary function, and so on. Yeah, a unary function is something which takes one argument. A zeroary function is a function which takes zero arguments. A binary function is a function which takes two arguments. Tertiary is function which takes three arguments. So everything ends with a r y. So therefore we call arity, arity, as the number of arguments a function takes. Okay. So now whenever we write a procedure lambda message.arg, so I could actually write more arguments here, message 1, message 2, message 3 dot args. So in that case, what will happen is that the function has to take at least three arguments, or here in this case one argument before the dot, and whatever comes afterwards will be packed into a list called args. Okay, so that's why I'm using car args instead of taking one argument. Okay, so if we send push to this object, if we send the message push to this object, then it will set bang s to cons of char args s. And if we send pop to this message, what should happen? Hello?
So
Hello?
we need to check if S is empty or not.
Uh, Actually, let's not check for pop. Let's not check that. Let's have another EQ for that particular purpose. Message is empty. So now what should this return? This should return. This should return what? EQ.
Null of S.
Yeah. S and nil. Yeah, that's fine. So let's assume that whenever a user takes this stack, he will, before popping, he will verify that this is not empty. Yeah. So let's just let's pop, assuming that pop always the list contains always one element. So now what should pop do?
Sir, set bang S, Cooler of S.
Set bang S,
Cooler
Cadar.
of S.
Yeah. And what should you return?
Uh,
S.
S.
Yeah, but you can't return char of S because we have already set S to char of S. Yeah, so that element is lost. You understand the problem?
Sir, we can have a let defining first
Yeah.
to RFS.
So we can have a local variable, local or temporary variable, temporary binding, which binds, which takes the char of S and stores it in that, and then we can do this. Yeah. So let's have a let, and what should it do? So let's have a pop, or let's say temp. So let's take that temp to be char of S, and set bang as cutter of S, and what should you return? Should return the temp. Yeah. Is that clear?
Yes, sir.
Okay. So now message unbounded identifier in message. Okay. So X. So let's have also an EQ. Let's just print, let's have a list also, just to print that S. Okay. So if I say Y with the list, it will give me undefined, because what is that? No, it's not Y, it's X. X with list, it just says empty list. So if I say X push 4, and if I say X list, now it is 4. If I say X push 5, and if I say X list is 5 4. If I say X push 6, X, it's 6. Now if I say X pop, turns me 6. Now if I say X list, says 5 4. Okay, so seems like our list is working. All right, so now let's do a now. So I did this one. So let's see. You have to do a data structure now. What are you going to do? Any suggestions? Any suggestions?
Sir, which data structure?
Yeah, that's what I'm asking. List all the data structures you know.
Q or
Yeah, Q is just like this. It's just yeah. So there is nothing, no difference between stack and queue. And anything else? List, stack, queue. Can you do binary search tree? Binary search tree with insert and delete and yeah. Can you try binary search tree now?
Yes, sir. We'll try that.
Yeah. Do binary search tree. So you try that. I'll come back in 15 minutes. Okay. Hello.
Okay, sir.
All right. I'll just, I'll see you in at 11.
Okay, sir.
Okay.